Hello, everybody, and welcome to today's webinar, How to Visualize IoT Data in Splunk. We are very excited to have Dominic, Falk, and Philip from SVA talking today, as well as Ronald from Splunk. We'll kick off in a minute, but before we start, I want to let you know that all participants are muted, but you can ask questions during the webinar by clicking on the Q&A button in your control panel. There will be around 20 minutes Q&As after the session, in which we will try to answer your questions. If we can't answer them all, they will be answered on our community forum, and the link will be shared with you afterwards. Additionally, we will also start a quick poll during this Q&A session, and we would be very pleased if you give feedback on this webinar. And I also want to let you know that this session will be recorded and shared with you afterwards. And I think now this is everything you need to know right now, and we can start. So I'm happy to hand over to Ian Scarrett from HiveMQ.
Thank you, Verena, and welcome everyone. It's great to have you. My name's Ian Scarrett. I'm the head of marketing at HiveMQ, and very happy to welcome our friends and partners at SVA and from Splunk. This is the interest in this webinar has been very high for us, and so we're really looking forward to presenting it to you. So we're going to start off with just a brief introduction to HiveMQ, Splunk, and SVA, and then we'll get into the heart of the webinar. By way of introduction to HiveMQ, HiveMQ is a small startup just based outside of Munich, and we're about 30 odd employees. We have kind of a great brand name list of companies in the automotive industry and in manufacturing, industrial control, all the way through to different types of connected products. We have over 100 customers in production in doing IoT solutions around the world. What our customers do are kind of the typical use cases that we see, or we have kind of connected car is probably our most dominant use case, where kind of actually today, if you bought a BMW or an Audi car, the connectivity would be done through HiveMQ. We also have a number of large manufacturing installations where people are kind of creating smart manufacturing or connected factories with HiveMQ. Logistics, so in terms of fleet management, we have companies doing fleet management with HiveMQ. We have a drone manufacturer doing real-time tracking of their drones as they fly across cities with HiveMQ. In telecommunications, we have digital set-top boxes being instrumented with MQTT and HiveMQ. And finally, we have a number of different types of connected products that are doing the connectivity between the product and the kind of the internet, the cloud, using HiveMQ. So it's a broad set of use cases that we have, and so it's very exciting, kind of the different types of customers that we can kind of bring forward. What kind of HiveMQ offers and kind of what these customers are doing is all based around a protocol called MQTT. So just a quick introduction to MQTT for those that might not know much about it. It's probably one of the de facto standards now for messaging protocols for IoT. So if you're connecting any type of device, how you move data, how you move messages from the device to the cloud, and how do you send commands from the cloud back to the device is often done with MQTT. All major IoT platforms support MQTT, including HiveMQ. MQTT is based around a publish-subscribe type protocol, where the clients, different types of clients, will be able to publish information, and different type of clients can subscribe to information based on the topic ID, and the broker is at the heart of that communication. This type of protocol is kind of some of the characteristics of it is it's very kind of requires a lot kind of minimal bandwidth. It's very bandwidth efficient. The payload, the message size is quite low. The protocol itself was developed about over 20 years ago in the oil and gas industry, where kind of network bandwidth was at a premium. So kind of they really structure it to be minimum bandwidth requirements. The other characteristics for oil and gas and kind of things like connected car is it's designed for unreliable networks. So kind of things like session management are built into MQTT. And finally, kind of it's also very good for doing bidirectional messaging. Things like HTTP are very good for sending telemetry information to the cloud, but HTTP is actually very hard to send information back. And MQTT is set up with the publish subscribe protocol to send information back to an individual device or a fleet of devices. And finally, for reliability, it has 3 levels of quality of services defined within the protocol. Very quick introduction to MQTT for people that might not know. So HiveMQ itself is a platform. We provide a MQTT broker that works in a very high kind of a cluster environment for high availability and high scalability. We can work across different cloud environments like Azure, AWS, Google Cloud platforms. We can run on just a on-premise data center on a Kubernetes installation, or even on kind of any virtualization technology that you might find in an on-premise data center. The device kind of connect into the platform. We have a control center for doing monitoring, observability of your IoT application, and also we have the ability to write extensions, which is going to be we're going to show an example of an extension in this webinar, where you can actually redirect your MQTT data and put it into another enterprise service like Splunk, like Kafka, like MongoDB, et cetera, et cetera. So a very flexible platform that we provide for our customers. So I'm going to skip over that just in interest of time. So for this webinar, we are going to be talking about our partnership with SVA, which is a large system integrator in Germany. They have a lot of experience of working with Splunk in their enterprise customers, and they're seeing more and more of these enterprise customers wanting to extend what they use Splunk to IoT data, and this is what we're going to talk about today. So without further ado, I'm going to kind of now turn it over to Ron from Splunk to give a brief introduction to Splunk.
Okay, thank you, Ian, for this kind introduction, and also thanks for having me here and being part of the session. I right now give you a brief introduction about Splunk for those who don't know Splunk, so that you can see what we do in general, but also how you can leverage this powerful combination of HiveMQ, SVA, and Splunk to build your own IoT-analytics platform. Yeah, my name is Ronald Persul. I'm a sales engineer and also an IoT subject matter here in EMEA. First of all, I have to talk briefly about the forward-looking statement. So we are a publicly listed company. So just make sure that you will base any buying decision based on the most current technology. So this concerns only the next couple of minutes of my part. So now, who is Splunk? So actually, we consider ourselves the data to everything platform. So basically, we want to make all our customers' data accessible to drive business decisions and produce business outcomes. So our history is log data. And when you talk about IoT, this is actually also logs. Actually, it's a very small log. It has a timestamp. It has a measurement. So this is also why we believe IoT is is a perfect use case for us. So 92% of the Fortune 100 companies rely on us. We have more than 6,000 employees, and in fiscal year 19, we reached approximately 2 billion. So as you can also see, we have many patents and customers, but we also have a strong partner ecosystems. And I'm very glad that we have dedicated Splunk partners like SVA supporting us, especially in the IoT business market for today's session. So what's so special about Splunk? So we believe that every company has a universe of real-time data. And as you all know, new data sources are coming up, and data is increasing constantly. So if you have a look at this picture, yeah, and for our customers, this means that you can create more opportunities, but also more threats are evolving than ever before, and you need to be able to handle all this kind of data and information. And Splunk is the platform to ingest and cover all of this. So let it be RFID chips, let it be sensors, devices, robots, but it could also be your network, your corresponding network, your infrastructure, business applications, databases, actually everything that you need to run your daily business. So, and how do we achieve this basically? So first of all, we want to make sure that our customers can act on their data. We support them by providing the ability to investigate, to make the data searchable. Then as a next step, to monitor. And finally, advanced analytics capabilities, so that you have end-to-end capabilities for actually everything you need to cover, also in the context of IoT. So we support data regardless of the structure, unstructured, semi-structured, structured data. It could come from any source. And if there's something missing, we have partners and powerful combinations like HiveMQ and the Splunk, the SVA team, building custom connectors. We support data at any time scale. And basically, the Splunk platform can be used for different kinds of use cases. Let it be IT, OT, security, app dev or DevOps, which is the new term, but also basic analytics. So when we now have a look at what can Splunk do in IoT. So in general, I would say we see three pillars. First and foremost is the Industry 4.0 and industrial IoT. And actually, we can do everything starting from asset monitoring to predictive quality and maintenance. But also, we support our customers with OT cybersecurity. So we are the leading SIEM, which is security, incident and event management vendor with a long experience in information security. And we now extend our footprint and invest heavily in securing your industrial assets. And finally, if you have any kind of connected products, you can ingest all your data inside of Splunk to do any kind of monitoring, but also you can use it to monitor your infrastructure, which could be on-premise or in the cloud, but also, and you will hear more about that, you can use the extension to monitor your HiveMQ environment. So this is just a short list about which companies are using Splunk, mostly starting from aerospace to semiconductor, food, beverage, and beyond. So do not want to spend too much time on this, but you can also see very big brands and feel free to check our homepage for these references. Before I hand over to the SVA team, just a few words about the collaboration between Splunk and SVA. So they are Splunk partner since 2016. Also reseller, managed service provider, providing professional services with over 30 Splunk certified professionals. So SVA has been awarded the Global Marketing Partner of the year 2020 with the focus topic with Splunk, big data analytics, IT operations, security, and IoT. And as Ian mentioned, we think and believe that the combination of HiveMQ, SVA, and Splunk is really, really great. And I'm glad that we have trusted full stack implementation partners for IoT engagements like SVA. So that's it from my side. And then I would hand over to Dominic.
Thank you very much, Ron. Perfect. Then, yeah, hello from the SVA side. So we have just heard about these two great technologies, Splunk and HiveMQ. And now we're going to learn, as soon as my presentation pops up. You should now see the presentation in full screen mode, how we put them together to form an IoT end-to-end solution. So my name is Dominik Pilat. I am allowed to lead the IoT team at SVA. Who is SVA? So we are the largest owner-operated systems integrator in Germany, with over 1,600 employees all over Germany. And out of these 1,600 people, more than 1,000 people are technical consultants who integrate systems. So yeah, what does that mean? So we take vendor products like HiveMQ, like Splunk, and many other vendor products, and put them together into IT solutions for companies out there and integrate into their business processes. And we do that in many solution areas, from data center over end user computing to IT security. And today I'm going to focus on the solution area and the business unit of big data analytics and IoT. We are very proud to have the largest business unit of this kind in Germany. We have more than 150 technical consultants in this business unit that take care of basically anything you need for analyzing data and large amounts of data, from building up the infrastructure for big data, building up Kafka and Hadoop, doing the business intelligence, doing the data science analysis, with a specialization on Splunk. We've heard it, more than 30 certified Splunk technicians in our business unit, providing managed services for many big data solutions. And yeah, you guessed it, we have also a specialization in getting things into the mix, and in Internet of Things, and getting data out of industrial devices, and building IoT solutions from it. So this is the Competence Center IoT, and I always like to start this presentation, or the presentation of the Competence Center IoT, with the faces of the people who, and that's the most important feature of these people, love IoT. So every one of these guys, if you wake them up at 2 o'clock at night, you ask them, what do you do? IoT, that's what I do, that's my life. I love it, So they are developers, architects, consultants, business consultants that deliver IoT to our customers. It's 15 people today. At the beginning of next year, it will be 18 people, and we are steadily growing. And currently, you are talking to these three people. So next to myself, it's Falk Flössl and Philipp Redlinger. These two have among others, developed the HiveMQ Splunk extensions in our team. Falk Flössl is a brilliant developer with a focus on getting data out of machines, and also combining nice IoT solutions like Splunk and HiveMQ, and furthermore an expert in using Splunk for IoT use cases. And Philipp Redlinger is a very good architect and consultant who works with our client companies to find the right IoT solutions for their use cases, and making sure they are built in time and in budget. So this is the team. What is our mission? What is the mission of our team? We want to make people's lives better using IoT technology. And how do we do that? We solve the technological puzzle that is IoT, because it can't be easy. So if you have a solution, a solution that is, let's say, a fixed solution, an easy solution for IoT, it's most likely a silo solution, a black box that works perfectly for one use case, but doesn't scale, doesn't have any flexibility, any openness, and that's not what we call IoT. We say IoT has to be organic, IoT has to be able to grow, to scale, has to adapt new use cases, and then the consequences, it is complex. But that complexity is just another awesome challenge that life poses for us, and we love solving these complex puzzles for our customers, putting everything together you need to build up an IoT solution. And in this case here, what we're talking about today, well, we've taken two puzzle pieces. One of them is HiveMQ. HiveMQ, from our point of view, is the enterprise MQTT broker. So HiveMQ takes care of connecting the devices, the gateways, the sensors, getting their data, being able to send data to them. And on the other side, you have Splunk, which is an enterprise-grade analytics platform, which can dashboard the data, analyze the data, survey the data, so do all kinds of magic with data. And of course, we can have a project with a company where they say, we want to use both of those, and we just have, you know, Falk going there, or Philip, or some other guy, yeah, and connecting these two components and saying, here, there you go, now it works for you. But we said, hey, this combination makes so much sense. We will invest the extra time. We will build a standard solution that connects both components, and that is our HiveMQ Splunk extension that then gives us the ability to, yeah, build or simply and quickly build a reliable and scalable enterprise IoT solution out of these great products. So what are you going to expect today? We are going to, of course, show you this extension today. We are going to look at the archetype of use cases. Yeah, a smart factory, a smart factory built of all the components that you'd expect in a smart factory. We will present the use case to you, and we have such a smart factory built in Wiesbaden and in Dresden with actual smart factory data and smart factory or factory protocols running over it. We will show you that use case. We will then tell you how we connect to that data and introduce our HiveMQ Splunk extension. So we're going to show you how it feels like, how you can configure it, how you yourself at home can start it up and use it for connecting Splunk and HiveMQ with each other. And then in the last part, we're gonna reap what we sowed before, get the fruits of our work, and show you how we have smart factory insights using Splunks. So having the dashboards, having the insights to really understand what is going on in that factory, because now we have the entire system and can get that data. So buckle yourselves in, keep your arms and legs to yourself. I'm giving over to Falk.
Hello, everybody. Nice that so many people came here to look at what we do. I would like to set the scene first with a typical smart factory, or in this case, not so smart factory at first. So this small factory wants to produce candy cane company candy canes with our drill mill stations and our varnish station. So like everybody knows, candy canes are produced by having a big block of sugar, drilling it, milling it, varnishing it, bam, and selling it. So, but here come a few challenges for us. For example, what happens if we have several production lines next to each other? We probably want to compare them to know which one is the best one, to take a look deeper why it's working better than the others, and use that knowledge to enhance the others. Also, we would like to probably compare these two drill mill stations, which hopefully are the same. But if not, we want to drill down on the data to see where the problem relies or where enhancements are possible. To do this, we need something to work with the data. So what we want is a good or the best visualization and analytics platform. And for us, this is Splunk. Splunk has an awesome way of figuring stuff out in your data in a very, very fast fashion. So here's our target, what we want. And next thing is we need the data out of our example PLC right here. The PLC itself right now is like a silo. So it has data, it works with them, it controls stuff, but from outside we can't look into it other than maybe an HMI that is right here or something, but it's very central. So we need it elsewhere. So what we do is we use IoT gateways with our software to read the data out of the PLC and make it accessible to other systems, like Splunk, for example. To do this scalable, professional, and safe, we use HiveMQ to have a backbone for our data pipeline to be safe that everything comes to the target and nothing gets lost. The good thing about HiveMQ is it is scalable, so I can have a cluster, and next to other things, we also can create extensions, which is what we did. My colleague Philip will tell you something about our extension later. So with these extensions, we are able to get all the machine data into Splunk, including the HiveMQ metrics, like how many MQTT clients are connected to it, how many messages are going out, etc., etc. And what you can see right here is how we upsmart the factory from the field level to our visualization analytics platform, Splunk. Okay, we just didn't do this on paper. We have hardware to prove that that it works. So we have 2 demo factories, like Dominic already said. We have one in Dresden. Maybe you can see it behind me, or here at least. We have one in Wiesbaden, and both are producing machine data, which we connected to our HiveMQ instances. We have 2 instances, one single instance and a cluster, just to show you later what the difference is between a cluster and a single instance if we take a look at the parameter in Splunk. So we added our extension to all the single instances. We publishing the data to it, and our extension is now able to push all the data to our Splunk endpoint, including, as I said, the HiveMQ metrics. The next thing I want to show you is how do our demo factories work. So let's take a look. It's this little thingy right here, and also in the back of mine. And I would briefly introduce to you how it is built up. First of all, like in the example factory for the candy cane, canes, we have 3 stations. We call them LED stations because they show what they do with these LED panels. This one, the left one, is supposed to be a drill mill station. The center one as well, hence LED-C, LED center, and LED right. This one is for varnishing. Sometimes you will notice that I'm pressing buttons right here just to simulate that this station goes down, has an error, and we want to see this later in Splunk. Also, this right here is our IoT Gateway, which I mentioned earlier, with our SVA software, the factory data bridge, to get information out of the PLC. The PLC itself is on this Raspberry Pi with a CodeSys soft PLC software. It offers OPC UA server, and our software reads it and sends it to HiveMQ. So much for the small demo introduction. I would like to get to my colleague Philip Radlinger right now. He will show you how the extension works. Have fun.
All right. Thank you very much, Falk. Hello, my name is Philip. Dominic already introduced me, and I'm very happy to introduce to you the HiveMQ Splunk extension that we just recently developed. So you should be able to see my screen now with the presentation. And yeah, first of all, so Falk already introduced us to the Pocket Factory side of the demo. So we are having a little setup with a demo showcase factory that is pushing machine data via the MQTT protocol towards the HiveMQ broker. So the HiveMQ broker is the central piece of your IoT infrastructure. It can be set up for scaling, for example, in a clustered fashion. It can be set up in a single instance. It can do horizontal, vertical scaling. So it is very nice to have the data here already. However, if you want to leverage the powerful analytics and machine learning capabilities to generate insight from your data, you would need to have it into Splunk. And that's why with the help of our HiveMQ Splunk extension, you can transfer the data in a safe and secure measure, and also in a scalable way towards Splunk. So you can make use of it there and generate use cases like digital twins, predictive maintenance, and several others. So first of all, I'm going to explain you a little bit about the characteristics of a HiveMQ enterprise extension. So HiveMQ already has a kind of a rich ecosystem of extensions that enable it to do things beyond its basic capabilities. So for example, there's an extension for Kafka. So Kafka is a distributed streaming platform, which is very powerful in its own way, and HiveMQ is able to connect to that. We have a security extension that was developed by HiveMQ, and it adds even more security to your deployment. And now the new kid on the block is the Splunk extension, which allows you to reach out to Splunk and leverage these analytics capabilities that you have inside of Splunk. And it was developed by SVA and is maintained by us as well. So you can use all of these nice extensions in combination. So you can use the security extension to make your deployment even more secure. You can use the Kafka extension and the Splunk extension all right next together. So there's a isolation of these extensions, so they can be run within HiveMQ next to each other, but they are isolated from each other. So if there's an error in a configuration with one of the extensions or something happens, then all the other extensions are not affected by this. So they cannot interfere with each other. There's the possibility of having a hard reload and start and stop during the runtime of these extensions. So basically you can make adjustments to your extensions. You can reconfigure them if you need a different setup, and you don't need to shut down your whole HiveMQ cluster for this. And you can just have the changes be reflected on the fly by the hard reload. There's the capabilities of vertical and horizontal scaling that the extensions benefit from. So HiveMQ can scale on multiple cores on the same machine or also on multiple machines, and these extensions can leverage that. And HiveMQ can act as a provider of authentication and authorization. So it has also a nice integration with enterprise directory systems, for example. So for user management, you can use Active Directory or LDAP, and these extensions can build on that as well. So why should you integrate it into HiveMQ in the first place? Well, you could also transfer data by spinning up a HiveMQ client, for example, a MQTT client that subscribes the topics and transfers it to another system. You can have that in a Docker container, for example, or you can also integrate it into Splunk. In theory, you could do that. So why should you do it with HiveMQ? So first of all, the HiveMQ SDK allows you to have a seamless integration into HiveMQ. And as I already mentioned, the extensions benefit from all the enterprise-grade features of HiveMQ, and you get support from HiveMQ and of course from SVA as well. So for enterprise settings, that is definitely beneficial. And you can have one solution that is capable of forwarding MQTT traffic as well as HiveMQ Metric, so the operational stats of your HiveMQ cluster itself, to the Splunk HTTP event collector. So the HTTP event collector is the native interface for Splunk where it can receive traffic. And there's a possibility of buffering and requeuing messages. So in case there's a network outage or your Splunk cluster has issues, you can just requeue messages within HiveMQ and send them later on when your cluster is up again. Or also you can determine another endpoint to send them to. So in case one of your Splunk nodes is down and you want to have a backup node for high availability clustering, that is also possible. So you can just transfer the traffic to another Splunk indexer node. There's only one single file that you need to configure for having all the transmitters. So transmitters are the little objects that are responsible for forwarding all the traffic and metrics to Splunk from HiveMQ. We will talk about them in detail on the next slides. You can also define SSL or TLS certificates in case you want to have strong encryption or client-side certificate authentication. Then you can do that also here within this configuration file. And of course, if you have multiple HTTP event collectors on the Splunk side, you can also set up the way they should be addressed exactly in that single file. And of course, From an architectural standpoint, you are using systems in a way they were designed for. So the purpose of HiveMQ is handling messages from MQTT clients, and of course also being able to hand out its own operational metrics to third-party systems. So you avoid technical debt if you use a native extension to do it, to forward messages to Splunk with HiveMQ. And you will also use the native endpoint in Splunk. So Splunk has these HTTP event collectors that shall act as the interface for third-party systems. And so you are using all your tools exactly in the fashion they were designed to be used with. So what is an alternative? And there's also, I think, a vendor that does that for his solution is having a Java virtual machine on one of your Splunk indexer nodes and running a MQTT client within it. There's several downsides to this setup, because it will be only possible to subscribe MQTT topics with it. So you will not get the metrics from the HiveMQ cluster. And it also scales not so easily. You would need to spread a Java virtual machine across all of your Splunk indexer nodes if you want to scale it horizontally. You would need to allocate more RAM manually if you want to use more of the resources of the Splunk node itself, and it would also chip away at the resources of the Splunk node. So Splunk also needs some of that. And it would be difficult to administer as well, because you would need to dump all the SSL certificates, for example, within the JVM key store on the Splunk nodes. And it would not be easy to keep track of the state of the whole MQTT clients that you run within your Splunk indexer nodes. So you might reconsider that choice if you want to have a production grade and large scale setup. Then it might be easier to just go for the native extension and have a perfectly integrated solution that will also benefit from the strong capabilities that both of these systems already bring out of the box. So how does the extension work actually? So as I said, there's a way of having a flexible but only one configuration file. So it works using transmitters that are responsible for forwarding traffic as well as metrics. And all of them are self-contained objects. So we follow the logic of the HiveMQ extensions as well here. So they are isolated, and as well as our Splunk extension is isolated from other extensions. These little transmitter objects that are forwarding topics as well as metrics are also isolated from each other. So they can be configured in an individual manner. So they can serve different use cases, different setups for various scenarios. And also you can have an arbitrary number of transmitters. So you can have one transmitter basically for all of your topics, or you can have one transmitter for all of your metrics. So that is the only distinguishing between these transmitters, is that one type of transmitters is responsible for transmitting topics, and the other type of transmitter is responsible for transmitting the metrics from the HiveMQ cluster. So there are two sections to the configuration, which I will show you later. And you can configure them to use different Splunk HTTP event collectors. The HTTP event collector itself can be spread across multiple nodes in your Splunk cluster. So you can use that for high availability features or having load balancing between the nodes. And you can also configure the transmitters to share one endpoint in Splunk. And you can also use the transmitters to configure them to talk to a whole another endpoint in another Splunk cluster. So it's not only limited to one cluster, and the cluster can also be based in the cloud, for example. So if you use the cloud offering of Splunk, or if you have a partner company that runs your Splunk instances for you, then you can also address these use cases with that configuration. So to give you a little more details about the configuration, which is basically the cornerstone of our extension. So the configuration is a file in JSON format, which resides in the installation folder of your HiveMQ extension. And yeah, there are many things that you could want to consider as having a flexible way of adapting to different needs. So for example, when it's about transmitting messages from IoT devices, well, you might want to power a live dashboard in Splunk with them. So you might want to keep a very low batch size of messages. So you basically want to have only one message that arrives and is being transferred to Splunk right away. So it can be power the dashboard almost instantly. But you can also want to have some micro batching or some batching use cases where you want to collect a couple of messages before sending them. You might want to define your sending intervals. You might want to define the encryption. So you can say, okay, I want to have a TLS certificate, which is self-signed if you want. You can have it signed by a public authority, and you may want to change that later on. And all of this can be done in the base configuration part of our configuration. So what you can do here is define global settings for all of the transmitters that are being created later on. And also you can define the default HTTP event collectors that should be addressed in Splunk. You can define message time to live, for example, which is another setting that will define how long the messages are being kept in case of network outages, for example. And all of these settings will be taken as a template when you define the concrete transmitters. So we have one section that contains the MQTT topic transmitters. So as I already mentioned, there are two types of transmitters, and this is the first type. And you can define topic transmitters here as elements in a list. And the only thing basically that you need to add to get a transmitter is a list of topics. So you need to tell the transmitter, okay, I want to have several MQTT topics that you should be forwarding towards Splunk, and you can define that list here. You can also just flash a wildcard if you want to have a broader range of topics and not, so you're not forced to have a specific list of names in here. And optionally, you can override the default settings from the base configuration here with custom settings. So if you want to have a transmitter that is really focusing on powering real-time dashboards, but the rest of your transmitters is doing not this use case, but is supposed to power batch transfers, then you can also set it here in a way that you define a smaller batch size here, so batch size of 1, for example. But the rest of your transmitters, like the second one or any of the other transmitters, can just inherit the settings from the global configuration. So you would only need to make one adjustment, and you could serve a whole another use case with this specific transmitter. And the same applies for the metric transmitters. So that's the third section of the configuration. And here as well, all you need to do is specify a list of metrics that you want to have forwarded to Splunk. And also you can flash a wildcard here. So you don't need to tell it exactly all the metrics that you like to have. And you can have an arbitrary number of metric transmitters as well. And they will also just pull all the settings that you don't configure explicitly within their own configuration from the base configuration. So once you start HiveMQ with this configuration file in our extension, it will just spin up all of these transmitters one after the other. And as I said, the transmitters are basically standalone objects that will forward data exactly in the way they were designed to. And so you can use them for different use cases. So as I already mentioned, the first transmitter might be a real-time data transmitter that is responsible for powering a live dashboard or for having real-time analytics in Splunk. So it will basically not wait until a certain number of messages has arrived. It will just send any incoming traffic right away. And for purposes of load balancing or high availability, the HTTP event collector that it addresses is spread across 2 different Splunk indexer nodes. So in case of one goes down, doesn't matter, there's still a second one as backup. So the next transmitter, for example, is focusing on batch data. So you can tell it an arbitrary number of messages to collect, for example, like 100 messages, and it will wait until 100 messages have arrived, and only then it will forward them towards Splunk. And it shares an HTTP event collector with the first metric transmitter. That is a transmitter that will just forward all the metrics. So you flash a wildcard in the configuration, and then it will just take all the metrics that give you information about the state of your HiveMQ cluster and forward them to Splunk, where you can build dashboards, for example, and have monitoring applications. So you always know about the health and about the workload on your HiveMQ cluster. And it also uses a custom index. So indexes can also be defined here in the specific settings. And a index is a concept in Splunk that is used to store and search data. So it kind of relates to a table in a traditional database system, but there are some differences, but it's kind of the same. So the second metric transmitter is doing what I also told before. It is sending data outside of your company network to an external service provider, which is here the Candy Cane company. It runs its own Splunk instance, and it helps our IT department in operating the infrastructure. So it offers operational services, and therefore it needs operational critical metrics of our HiveMQ cluster to be able to help us monitor and maintain it. And because the data needs to leave your company's own network for this, go over the internet into the network of another company, you might consider here using strong encryption and certificate-based authentication, which can also be configured in our JSON file. So before I hand over to Splunk for the final part, and where he shows you what you can do with the data in Splunk, I will just give you a practical example of running the extension and how it feels and what it does. Because like the first thing that you want to do naturally, if you get your hands on a new piece of software, is you want to run it right away, see what it does in action. You don't want to spend hours reading documentation, how to set it up properly. Of course, we provide you a documentation, and it's very recommendable to have a look at it. But also in case you miss something, or if something goes wrong, our extension will be there to help you. And so I'm logged in onto one of our HiveMQ nodes in our little demo setup where we have a cluster and a single instance. So now I'm on the first node of the cluster. And what you see here is a very basic configuration file. So it has a global part, which starts from the beginning and goes until here. And then we have a part with the message topic transmitters that starts here and goes until down here. And then we have a part with the metric transmitters. So there are some errors in this configuration. I'm not going to talk about it anymore. I'm just going to show you what happens if you run our extension with a faulty configuration. So I just stopped HiveMQ to show you the configuration. And now we will restart HiveMQ, and on the right-hand side, we will see the logs. So what does our extension say if you run it in an incorrect setup? So need to enter the password. So HiveMQ is starting. Yeah, we see the starting messages. The HiveMQ server is started, but we see also two error messages. So HiveMQ was starting its extension system, then it started our extension, and during startup, our extension had some smart checks that it ran through the configuration, and it noticed, okay, something is wrong here. I will not work properly. And it tells us, so error interval in milliseconds cannot be 0 or less, and error source type not set. So source type is also a concept in Splunk. Splunk needs a source type to be able to parse the data correctly and to index them in the correct way. So you need to set that at any case in a configuration. And because of this, our extension was disabled. So because it will not work properly, it doesn't even come up in the first place. It gives you a warning, it gives you the error message, and then it just shuts off. But HiveMQ itself is starting. So that's what I'm talking about in extension isolation. Our extension cannot destroy anything or corrupt anything within your HiveMQ cluster. It can only shut down itself, and that's the worst thing that can happen to it. So now we are going to correct these two little errors. So it tells us interval in milliseconds cannot be 0. Yeah, that makes sense. Why would you have an interval of 0? So we set it to 10 seconds. It's in milliseconds. So the smallest thing you need to give it here is 1 millisecond, which is basically real time. We'll take just 10 seconds as the forwarding time. And another issue was the source type. So you see that field is even missing completely here. So someone was sloppy in setting up the whole thing, but it's not an issue. We will just provide it with the source type, which is HTTP, because we address the HTTP interface of Splunk. And then we should be good to go. So now we don't even need to restart the whole HiveMQ cluster. So there's the capability of hot reloading the extension, and therefore we just need to remove a disabled flag that was set now when the extension disabled itself. And then the hot reload should kick in. Yeah, we see it on the right side. It just starts up again, but still there is something wrong with it. So the extension started successfully. We don't see any errors anymore, except for that one down here, which is kind of related. It's also not a critical error. It does not shut down the extension. But we received 3 lines of warnings here. And it tells us this entry was detected as unavailable in whitelist and will be ignored. And there's a hashtag. Okay, so what does that mean? No metrics from whitelist are available in registry. And unavailable entries were detected in whitelist and will be ignored. And now we see there's this hashtag symbol, and it's supposed to be a wildcard for all the metrics, as it seems. So what we want to have is all the metrics of HiveMQ be sent towards Splunk. But the problem here is that that is the wrong wildcard. So it's the wildcard for sending MQTT topics. So it should be actually in the topic transmitter configuration and not in the metric configuration. So for the metrics, you want to have the asterisk symbol actually, and not the hashtag symbol. So that's why we receive a warning here. The extension still comes up because, as I already mentioned, the transmitters themselves are also self-contained and encapsulated. So an error in one of the transmitters will not affect the rest of the extension in the other transmitters, but we will just not receive any metrics. So the MQTT messages will be forwarded on this topic. This MQTT topic transmitter is not affected by this, but we don't receive any metrics, which is also not that great because we always want to know the state of our HiveMQ cluster. So we just changed the wildcard symbol here. And yeah, so for the hot reload to kick in again, we don't need to start the HiveMQ cluster once more, but we just need to disable our extension for 1 second, and then we enable it again. So we see extension stopped successfully. The HiveMQ cluster itself is still running, and now we enable the extension once more, and we see, yeah, it started. And we see a message, so it goes very fast. Hot reload really works on the fly. And we see that the total standalone wildcard was detected, and other entries in whitelist will be ignored, and all metrics from registry will be sent to Splunk. So what we can tell now is that there should be some data coming to Splunk. And if we go into our browser and log in on our Splunk instance, we see, okay, yeah, fresh metrics from HiveMQ have arrived. So we get some meta information as well. We get the name of our HiveMQ cluster that the instance belongs to. We get the name of the host. And yeah, I was on the first instance in our HiveMQ cluster, and right now it is sending its metrics as it's supposed to. So it's a long list of metrics because we had the wildcard here, and we get all of the metrics from the Java virtual machine that it resides in, as well as from the HiveMQ application itself. So every minute, new metrics will just fly in now in Splunk. And with that, we are ready to go and analyze and monitor our data in Splunk. And that is where my colleague Falk will take over again. Thank you very much.
Thank you so much, Philip. So let's share my screen again. You should see my screen right now. Yeah, should, right? And let's go ahead here. So please someone write me if I did it wrong and you can't see anything, but you should. So reaping what we sowed. Let's take a look at what we did right now. So as discussed, we have our factory data, our HiveMQ Metric data, and all are flowing now to Splunk on a scalable, in a scalable and safe way. And what we would like to do now is to show you what you can do actually with the data inside Splunk. So my mouse doesn't work. Here it is. So what we wanted and couldn't do was to overlap data between our factories. So we have the Dresden factory, the factory demo in Wiesbaden, and right now we are able to get graphs of the workload of our drive, which is the thing in the middle right here, which turns the work pieces. And now, due to the fact that the data are in Splunk, we can overlap them and take a deeper look at our factory side and compare them to each other in a very, very, very easy way. Don't worry, I'm not showing this only on the PowerPoint side, but also in Splunk as well. On the other hand, we have these cool little things that you can see right there. So now we have alerts in our system. Alerts are a cool way to push information back to you, like here has been a problem and here has been a problem. This is why there's this triangle right here. And now we have a reactive behavior in our factory. So the information that something went down comes to me. I don't have to look for it. I don't have to look at the machine and see, there's a red light blinking. I can get the information pushed to my phone, to my email, and yeah, other stuff as well. So for example, we could log alert events in Splunk, work with them, make statistics with the alerting events themselves. We can automatically run scripts in such a case to, let's say, try to fix the error on its own, like restart a service or restart a server, or I don't know, do something else, something cool, or write something to a database or whatever you want. You also can use webhooks to, for example, push the information into a Slack or a Microsoft Teams, or what else you have, right? And of course, send an email just to see it right there. What can be included in such an email is something I will show you in a few minutes in our Splunk platform. What else can we do? We can take a deeper look at our factory and analyze its behavior. For example, with the overall equipment effectiveness OEE, maybe the one or the other has heard of it. It's an important characteristic for the added value of production. Sounds cool. And it is, because you see, if you use the OEE parameter, you can have one gauge that shows you that something's off, right? It's in the red, it's not good. But I maybe don't know why, because the availability and the quality looks pretty good. So the machine is running, but oh, I see the performance is down. Why is that? So I just have to look at this one parameter to find the problem in my production. Maybe we're out of sugar. So everything works, but it can't do anything, right? So that is something to look forward to. All right, and another thing we can do now is we can work with our HiveMQ metrics, which is what Philip just showed us in Splunk. Those were live data that are flowing in right now, and we can work with them. So I will show you a very small sneak peek of our Splunk HiveMQ application, which we are developing right now to get even more out of our extension, HiveMQ and Splunk. Okay, so let's go hands-on and Splunk this demo. I don't have an alert, that's perfect. So this is our Splunk. This is what Philip just showed you. And this right here are the data that are coming in live. I can prove this by doing this and have a 1 minute window to show you that data are flowing in right now. So these are live data. You can see here's a bunch of data that came in at this particular point. And what is nice about this is with Splunk, you don't have to really put in something to get the data and filter the data. You can actually put someone who is not accustomed to Splunk in front of it and let him click a little. So maybe he just clicks on the job group and sees, oh, here are all my metrics for the messages that are flowing through my HiveMQ cluster. So I click on it, and it filters everything itself. It adjusts the search, and so I can, even as beginner, take a look at the data very, very fast. So live data, nice thing. Next thing is we choose to send our demo data in a specific format, which is not particularly necessary for Splunk. Splunk can almost do every message format there is, but we did it so we can use the analytic workspace. So we send the data as Splunk metrics in the Splunk metric format. And what you can see right here are some alerts. As I said earlier, I have to push a button to create an alert in our demo factory. This is what I did right here, which is where you see all these triangles that symbolize an alert. So as you can see, I worked hard for my money while Philip was talking. Maybe you want to know what the colors mean. These are severity levels. This right here is for a varnish error. So if I click this button right here, I hope you can see it. Then I create an error for the varnish station. Since we have only one varnish station, that is a high severity problem, and we have two drill mill stations. It is not a high severity problem, which is why they are green. All right, so these are alerts. You also can look at them wrong here under triggered alerts. And this view shows you a table with timestamps and the severity, where it happened and why. And you could take a look exactly at this one problem right here by clicking on this button and get more information about it. All right. Right now you can see right here, this is my varnish error, which I just clicked, disabling it. This is not a streaming alert. So there are streaming alerts that almost instantly tell you that here's a problem. But our Splunk instance is just a single instance and not a cluster. So I told it to evaluate it every minute. So if we wait a few seconds, we should see a cool little triangle right here. So nice, works. Okay. The other reason why we are using Splunk metrics is this tree right here. So we didn't configure this right here, okay? We just gave it names. So our LEDC, which is the center drill mill station, has a function, workload, etc. And this workload piece is here because the name is LEDC underscore workload. So this tree on the left side creates itself with the name of the metric. Due to this, we can very easily have cool little dashboard panels in a very, very fast fashion. So let's go even further. These are the overall information, that I want to split them by host. This one here as well. So we have the workload for LEDL, the left drill mill station, and the right drill mill station for both sides, for Dresden and Wiesbaden, in one panel just by clicking a few, clicks. Yeah, which was pretty easy and is pretty damn cool, I think. So to get the first information about our factory, this is a very fast way to gain insight. Okay. The next thing I would like to show you is an overview application which we built for our demo cases, for our small factories, to show you what, for example, is possible. Obviously, this can look a whole other way if you wish it. We created it like this to adjust it to our demo cases. So, for example, we have a station overview for our demo factories, for Wiesbaden, Dresden, and for all. And we have the drive, and we have the information, what's the actual workload, in average workload in this case, in the last hour. But I also could say, let's say 4 hours, or I do something crazy and put in a certain date range. I also can take a look in the last 2 hours, how many work pieces, so candy cane company candy canes, were produced by the left drill mill station in the last 4 hours. Or maybe I want to say in the last 24 hours. Or how did it look in Dresden? Ah, I see. Yeah, the Dresden, this hourly production always uses both. So, but as you can see, in the night, the Dresden demo was offline because it's here at my home and I want to sleep sometimes. So it only produces when I'm awake. And you can see here the how many candy canes were produced in which hour, which could be something that you could adjust for your own needs. Okay, let's take a look at our production overview. Human needs water. So what we can see right here is the current load for today. Also here you can adjust the time picker to choose the time. We get the information how many products were really produced in that specific time. So normally, what means normally? There was a time when we used ETL jobs for stuff like this. So we could only peek at information like this to certain times, right? And if the ETL job didn't work, then this information is missing. Right now, we work with streams of data here. So we can adjust the time picker to what we want and get the information right here in our dashboard. And this for Wiesbaden, for Dresden, for other countries if you want, or for all, so you can overlap them and have all the information in one panel that you need and that you want. Okay. Here are the errors of the stations and some blaming, which station was the bad one. In this case, the central one, which has 17 errors and the others only 13. Okay, so a very on top view of the factory. Now let's take a look at the OEE information, which I showed you something about earlier. So this builds itself up pretty well. So the right one station in Wiesbaden didn't have any errors. I can fix that because Dresden I pressed like hell, and here are a lot of errors, as you can see, which is why the OEE parameter, which is this one, isn't the best one. It has a percentage of 8.74. And if we want to take a look why this is, we take a look at the important information, the availability, which was okay due to the fact that the mean time to repair wasn't so high. The quality information, they are perfect or almost perfect, but the problem was our performance. We want almost 9,000 products in this time range, but we only have 981, which is why the performance factor is pretty low. Hence, our OEE is very low. But right now we know where to look and what to do and what we have to tweak to get a better OEE and, well, in the end, to make more money. Okay, so this is a small example of what you can do with the data. We can do way more with Splunk. You can add AI to analyze the data on the flow, to get information that you didn't have before and that you didn't think about before. So Splunk is a very neat way to integrate AI for predictive maintenance purposes, for example, and to overlap machine data, which we used here, to other sources like network information, or maybe activity log in a database. Maybe our machine needs a database connection, but the database was down. Our AI sees this, knows our production needs it, and contacts us automatically, so we can act proactively. Okay, and now I promised you a little sneak peek to our HiveMQ Metric application. It has 4 dashboards right now. I could start my, or maybe you will see something. I have a small program that that connects and disconnects 20, yeah, we can see something, 20, up to 20 clients. So we can see it a little bit moving right here, because yeah, this one works in Dresden, which is why you can see the current connections rose and they got down again. In Wiesbaden, it's all flat. That's why I needed this small script that connects itself to our Dresden HiveMQ single instance, because, well, our extension works too well. So here are no connection losses or something like this. It just works. But if something works, it's plain, that's boring. So you see, that is why I show you something about Dresden right now. It shows you everything you want to know about your cluster, like the MQTT 3 connections. If we would use MQTT 5 connections, you could see them right here. Unfortunately, we don't have any connected yet, so it's empty. Okay, again, you can use the time picker to get the date range, 7 days. I hope our single instance can do this, but it looks good. And again, we can overlap the data for the Dresden data and the data in our Wiesbaden HiveMQ cluster. Okay, so these are some information. On the other hand, we have debugging information right here. Again, it works just too well, so there are no dropped messages. Sorry, but if we had some, we could see them right here. We could filter them, we can overlap them, we can choose a time range, etc., etc. So what the admin wants. Here we have JVM information, so for the Java virtual machine, which HiveMQ uses. Also here it's overlapping for the HiveMQ cluster admin, probably very interesting information. Going over this right now. And on the last page, we have traffic related metrics like publish incoming and outgoing. And as you can see, this right here is our Dresden demo, which uses my little script, which is why there are outgoing messages. The Wiesbaden one doesn't have this right now. Ah, it does. So probably someone connected to it. Okay, so it does. Cool thing, good to know. Didn't know that before, but now we have our application. Awesome. Here we have an overview of our subscriptions. This changes over time, and the subscriptions that are in total to this particular moment. So even this is something we can have insights on right now. Okay, so this is Splunk. I would like to continue right here. The next good thing for you to know is our extension is already in the HiveMQ marketplace, can be downloaded. You can test it out. And a small Christmas present for all of you, the good message is you can test the whole thing out, which we did right here. You can download Splunk and use it for free. As long as you index 500 megabyte a day, it's okay. You can use it. You can download HiveMQ as well. Try it out for free. As long as you don't have more than 25 MQTT clients, and you can download and try it for free our Splunk extension for HiveMQ Splunk extension for 5 hours at a time. And that's pretty much it. If you have any questions, please feel free to contact us. The easiest way should be to write an email to Dominic, and yeah, he will do the rest. So let's have some questions.
Yes, let's go over to the Q&A session. So I will also start, as previously mentioned, the poll. So if you could take a second and answer the poll, we would be very happy. So let's see. So I've seen that you already answered quite a lot of questions. So let's give people some time to answer questions, to ask questions. But meanwhile, I can read a few questions that have already been answered. So, for example, someone asked, in the candy cane factory example, where is the HiveMQ SDK incorporated? In the IoT Gateway, in the PLC, or somewhere else? And Dominic answered, in our little factory, we used HiveMQ running on 3 of our servers. The IoT Gateway is running factory data bridge, our software to connect to the machine protocols, which sends the data via MQTT to HiveMQ.
Perfect. Shall we all get our cameras on and just let's say be there for incoming questions, and maybe also extend on these questions, because I of course I guess the question behind the question here is where can you run HiveMQ? And I think Ian said it perfectly. It can run on the cloud, it can run in the data center, so wherever you want to. What do you think, Verena? Shall we answer the incoming questions directly, or?
Yeah. So now there is an incoming question. So I would say we first answer the incoming questions and then extend on the already answered ones. So there is now an incoming question which Emmanuel asked: do you need a special payload format to be able to be read by Splunk?
Dominic, should I take this? Basically,
absolutely.
Yeah. So actually, it's you don't need to take care about the payload, right? As I mentioned earlier, it can be Splunk is able to ingest any kind of payload. It could be really unstructured data logs that you wanna search through, but it can also be structured data like JSON objects, right? Which maybe just be a timestamp, metric name, metric value. Right, and this is so we had the question about let's say what kind of differentiators against a Grafana, right? So I would say here this makes Splunk really special. One topic which makes Splunk really special is the flexibility when it comes about the data. So you don't need to think about how you store the data actually upfront.
Absolutely, that's one of the features that we love about Splunk. And another feature Falk mentioned: if you choose to structure your data in that metric type, yeah, then Splunk gives you these additional goodies of well, giving you that tree to search for data, giving you that whole analytics workspace where you can do a lot of things by clicking and easily having predefined visualizations and analytics capabilities.
Okay. Thank you. So let's go over to let's pick where is it? So let's pick this one. While HiveMQ handles transition data, which technology is used by Splunk to realize the storage of a data? And Ronald, yeah, answered Splunk provides its own. Do you want to say something to this one?
Yeah, I can say something on this, right? So actually, Splunk provides its own, let's say, proprietary way to store the data, right? As Philip mentioned, we store the data on something which is called an index, which is a file-based storage, and data is organized in so-called buckets. And actually, depending on how current the data is, or if the data is aging out, actually you can, for example, also store the data on a cheaper storage. So also when it comes to data retention and data storage, so we have here really powerful options and full flexibility. Yeah, how we store the data, and you do not need to rely on any kind of backend technology. Yeah.
All right. Okay. Thank you for this one. So Carsten asked a question: did you use any kind of device management in this example? If not, what kind of device management would you recommend? So Falk and Dominic answered this one, and Dominic said, in this example, we used Netfield.io as the device management. It is perfect for managing the gateways we use and our software running on them. Do you want to say something to this one, Dominic?
Yeah, this is just one of these answers where it depends. So there's a lot of device management software out there, many possibilities. Like we have built up a smart factory platform at I can actually say that name, at Mitsubishi's, and we have for device management solely used a device management platform for managing the gateways, because that was the use case there. It made sense. If you go smart product, for example, you would absolutely use something else. Yeah, right there. So that is absolutely a question that depends on the use case, and we would be absolutely happy to go into that conversation with you, and maybe come up with something that fits the bill.
All right. Okay, so there is another one asked by Edgar. He asked, what is the main difference between Grafana and Splunk?
Yeah, that's a really well, it's not an easy question, right? Because the comparison, it really depends on the use case. It's often a buy versus build decision, right? Because you have some open source technology, and if it's really enterprise grade, right? So there are some, I would say, the key differentiators is simply the maturity of the Splunk enterprise platform, the amount of years that we are on the market, the flexibility, the scalability of the platform itself, and many additional. So our strong ecosystems when it comes to freely available apps and add-ons, self-service capabilities, integrated machine learning, all that kind of stuff. Furthermore, we have also a couple of additional extra solutions where we are really a market leader, as I mentioned, in the IT security space, or also on the IT/OT operation space when it comes to monitoring, right? So that's, I hope that's useful as a first comparison. Yeah.
So I think that's pretty much it. So if there are no open questions right now, I think we can already close the session. Thanks for joining us today. We hope you enjoyed this session, and also a very special thanks to you guys, to Dominic, Falk, and Philip from SVA, and to Ronald from Splunk. It was really a pleasure having you as speakers today. And as I mentioned also in the intro, if you like to watch this webinar again, we recorded the session and we'll upload it on our YouTube channel. We will send out the link afterwards to you in a follow-up email, and then you get also a lot of information about the HiveMQ Splunk extension, and also contact details from SVA. So I think that's it. I hope you enjoyed it, and see you next time. So goodbye.
Thank you, everyone.
Thank you. Goodbye.
Thank you, everyone. Bye.
Yeah. Thanks for participating. Bye-bye.
Bye-bye.